Dear students, welcome to my channel. Main topic of this video is indexing and scoring in information system, and subtopic is other indices for text. So in this video we are going to see other type of indexes which is used in information retrieval, like suffix trees and suffix arrays with exercises. Now let us start. Other indices for text. Other than inverted file index, other approaches are suffix tree and suffix array and signature file. Suffix arrays and trees, faster for phrase searches but hard to build and maintain. Signature file, it was popular in the mid 1980s but inverted file overcome. For each technique, pay attention to search cost and space overhead, construction cost and maintenance cost for creating the index on a given text. Inverted file index limitation, it assumes text as a word sequence, limits certain queries. For example, queries such as praise are expensive to solve using inverted files, because even after getting the data from vocabulary, the lot of task is required to combine or arrange the data to get the particular answer. Not suitable for concept like words in genetic database. Introduction to suffix trees and suffix arrays. They are the space efficient and handle the complex queries efficiently. Drawbacks are costly construction, text must be available at query time, and results not in text position order. Versatility of suffix arrays and suffix trees. It views the text as a single string. Each text position is a text suffix. Suffix from different positions are lexicograpically different. Each suffix is uniquely identified by its position. So when we solve the problem on suffix arrays and suffix tree, these things will be clear. Comparison between the suffix array and inverted indices. Suffix arrays are suitable for broader range of application, that is genetic database. It can words or any text character, but it can index only specific points for retrieval, that is for example word beginning, and not suitable for retrieving the non-index point, that is the middle of the word. So every word is indexed from its starting position only. Concept of suffix. For example, A, B, B, C, D is a string. Now the suffixes possible are D, then CD, BCD, BBCD and ABBCD. Next statement is, this is a pen. Pen color is red. Now the suffix available are red dot, is red dot, color is red dot, pen color is red dot. Next is pen dot, pen color is red. Like this we can create the suffix for these statements. Suffix tree structure. A suffix tree is a trie data structure built over all the suffixes of the text. The pointers to the suffixes are stored at the leaf nodes. This tree is compacted into Patricia tree, that is compressing unary paths. Searching. Many basic patterns such as words, prefixes and phrases can be searched by simple trie search. Space inefficiency. Each trie node consumes 12 to 24 bytes depending on implementation. Even with indexing only word beginnings, it incurs a space overhead of 120 to 240% over the text size. Now see the example how to build the suffix tree and suffix array using the trie data structure and how it is compacted into Patricia tree. Now for example, data is AB and dollar is added at last. Now for simplicity we start the location from 1. So 1, 2, 3, 4, 5, data is stored AB dollar. Now we'll find out first the suffix pattern. Suffix patterns available are dollar, B dollar, AB dollar, BAB dollar and AB dollar. Now we will construct the tree. So first path is dollar, so dollar. Next dollar and B dollar, in the starting common is not there, so we make two branches. First is dollar and next is B dollar. Third is AB dollar. Now we will make the branches, that is here again common is not there, so three branches. One is dollar, AB dollar and B dollar. Next is BAB dollar. Now here B and this B is common, so one branch goes to B, then dollar, then another branch goes B and AB dollar, like this, B dollar and AB dollar. Next is AB dollar. Now here AB is common, so we can make the bifurcation here, that is branching AB dollar and here AB dollar. So in this way we are making the tree. Now we can see that this AB is continuous, that is one path. So we can use the Patricia concept and we can make like simple AB. Here also we can make AB here. Here also we can make the AB. Now this is the resultant tree which is arranged in ascending order. Now this tree is same as previous, only the paths are compacted and they are lexicographically arranged, that is in ascending order. Now for this tree it is AB, AB, then AB dollar, then B, the path started with the B, BAB, then B dollar, and finally is dollar. So in this way the tree is arranged in a lexicographical order. Now how to give this 1, 2, 3, 4, 5. Now this is our text 1, 2, 3, 4, 5. Now the path is dollar, fifth path is dollar. Now here dollar is there, so we are assigning the fifth. Now I will start with the first number. Now we see the first number is AB, AB dollar. Now why 1 is given? AB, AB dollar, we can see that AB, AB dollar is present at first pattern, at the first location. Next is AB dollar, AB dollar is present at third location. Next is BAB dollar, BAB dollar which is present at location 2. Next is B dollar, B dollar is present at location 4, and last is fifth is dollar. So in this way we are giving the number 1 to 5. Now here it is a suffix tree. Now we require to convert this suffix tree to the suffix array for space efficient implementation. Now here again is 1, 2, 3, 4, 5. Now we will write down 1, 3, 2, 4, 5, and under 1 the pattern is coming AB, AB dollar. Under 3 the pattern is coming AB dollar, and we can see that this is sorted. First start with A, then B, and then last. So in this way suffix tree gets created. Now we will see the next example. Now the string is XAB, XAC dollar, location from 1 to 7. The suffixes possible are dollar, C dollar, AC dollar, XAC dollar, BXAC dollar, ABXAC dollar, XABXAC dollar. Now when we draw, I have not shown step by step like this previous example, but you can make the practice of it and just check that your final tree should be like this only. So when we first draw, then every time we require to draw the new pattern, first we will draw with the dollar, then dollar and C, the two paths are there. Again no common is there, then three paths are there. One is A, one is C, and one is dollar. Next is again fourth path is there, but after that the paths are combining, so we require to make that. So for example, here we can see that one pattern is AC dollar and one pattern is ABC XAC dollar. We can see that A is common, so in this way we require to make the pattern, and this is again long tree, we can make compacted. For example, for this we can represent as a BXAC. Now the tree develop is we require to arrange in ascending order. Now this is a lexicographical arranged tree, so we can see that first branch is ABXAC, next branch is AC, then here the next branch is BXAC, C, then the branch start with the XABXAC, C, and this. So we are arranging. Now we can see that the first branch is ABXAC, ABXAC, it is stored at two locations, so 2 is there, so that's why 2 is stored here. Next branch is AC dollar. We can see that AC dollar start with the fifth, so fifth AC dollar. Next branch is BXAC dollar, BXAC dollar at third location. So in this way we are first creating this rough tree, then we are compacted by Patricia, and after that we lexicographically arrange, and based on that pattern's name start with the location, we are giving the location in the suffix array. So in this way suffix tree and suffix array get created. Now see the next example, banana. Then the possible suffixes are dollar, A dollar, NA dollar, NAN, A dollar. Like this we will get the suffixes. So initially start with the single node, and after that we require to add. And when we are drawing step by step, it is very easy to come to know that where to start a new branch, or where to make the branching, or where to add the particular nodes. So it is very easy. Once this diagram is completed, we require to just make compacted. So here banana we can make as a single string. Now next is nothing but the suffix tree, and here we are arranged in ascending order. Only here you just make the note that it should be 2 4 and it should be 3 5. because when we compare NA dollar and NA dollar, so order of NA dollar should be first and then NA dollar, and here also the order of NA dollar and NA dollar, so order of NA dollar should be first. So just make change that here first it is 2, then 4, and here it is 3 and 5. So we can take this. Now first branch is A dollar, here it is A dollar, so 6 is stored, and when you arrange the suffix tree into the suffix array, we can see that all pattern gets arranged in a ascending order. So this is the efficient storage of the suffix tree into the suffix arrays. You have to check that how that banana tree gets created. Now this is the example. Text is given. We have to find out the various pattern. We have to build the tree. Arrange the B in a sorted order. So first path is A B B C A. So it comes at the 4th location. So we are writing. And when we see the suffix tree, suffix array, so all is arranged in ascending order. So you just observe the text, suffix tree and suffix array, and it is very easy to draw the suffix tree, and after that suffix tree is easily converted into suffix array. Now we will see in real document how that suffix tree and suffix array gets created. Now this is a statement, this is a text, this is nothing but space, this is a text. A text has many words. Words are made from letters. Now in indexing, inverted file index, words dot and words, they are same, or text dot and text are same, but text dot and text are same, but in suffix arrays and trees, as we are finding out the, or it is used for the queries or special type of queries such as proximal queries or the queries with a particular structure. So we are creating the separate index for text dot and text, so they are treated differently. Now here what we require to find out which keywords are there, because it is always better to make the index on a proper keyword, not the other stop words or other words or other numbers. It is not beneficial. So here we are making the keywords are text, many, made, letters and words, and we are creating the indexing on that. So index get created at this location, at this location, at this location. So index get created at this location. So index points are selected from the text which point to the beginning of the text position, which are retrievable. So here if we given in a search that we want to find out the documents in which text dot word is there, so here we are getting the location like this. So we will get this answer. So index points are selected from the text which points to the beginning of the text position, which are retrievable. Keywords, we are making the index only on keywords, so that key terms or keywords are mentioned here. Now from the suffix tree we require to make the suffix array. So text comes at 11, text dot comes at 11, text comes at 19, many comes at 28, words dots come at 33, words come at 40, made come at 50 location, and letter come at 60 location. So these locations are there and we are sorting. So letters, then made, many, text, and we can see that in inverted file this text is same, that is text dot and text is same, and only locations are different, but here we are maintaining the separate because we want to search by the different types of queries. Now suffix trie and suffix tree. So when we make the inverted file, at that time we are using the suffix trie, and this is the suffix tree. Now L M, so we compacted here, so different branches are not shown. So MAD, then T, because one T is with dot, that is text dot, and one is only plain text. So T without dot, with dot, words without dot, with dot. So in this way we are, and this is nothing but the trie structure. This is not used in inverted file, this is the trie, and based on trie we can make the suffix tree also. So this whatever that entire path is compacted to the T, and when we create the suffix array. So here such type of structure is stored in ascending order. So this is the resultant suffix array. Suffix array provides the same functionality as suffix trees but with the less space requirements. Traversing leaves of the suffix tree in order yields all text suffixes in lexicographical order. A suffix array is an array with pointers to the text suffixes in lexicographical order. Space requirements are almost same as inverted indices with approximately 40% overhead over the text size. Supra index or indices. Now in the suffix array we can make the supra index also. Suffix arrays are designed to allow binary searches done by comparing the content of each pointer. Binary searches can be slow with large suffix array due to random disk access. Supra indices propose to improve the search performance. A supra index may be sampling of 1 out of B suffix array entries storing the first suffix character. Now this will be clear with the example. Now this is the suffix array for the given example, that is in which 60, 50, 28, 19, 11, 40, 33 locations at the text position, and at that letters made many text. This is nothing but the start with the particular word. Now if we make that supra index with particular value of B, so for example if we make the B, then we are storing the entry that is first and second in first part, then again 1 2 letters we will store, then 1 2 1 2 again 28 we are storing, then after that we are not making the entry of 90 but we are only maintaining the entry of 28. Now next is 1 2 1 2 1, again we are storing the text and again we are storing the this word dot. If we are making the B is equal to 3, then 1 2 3 1 2 3 like this, so we are storing only the entry of 60, then we are not maintaining the entry of this because it comes under the this particular portion, that is 60. Next entry we are maintaining 19, then after 19 1 2 3, so text dot and words come under the text, then next is word dot. So in this way we are making the supra indices by choosing the value of B. So when B is equal to 2, select every second entry from the suffix array and store the first characters of the corresponding suffix in the supra index. So if we make B equal to 4, we are storing only letters, and 1 2 3 4, that is up to this all comes under the letters, and next location we are storing is the 11, that is nothing but text dot when our B is equal to 4. Samples can be taken at variable intervals or based on the word change. So we either take that particular value of B or either we take the word change. So I will explain the example of word change also. For word indexing suffix arrays, a sample could be taken each time the first word changes. Extra space requirement for supra indices are modest, and the space requirements with the vocabulary supra index are the same as inverted indices. Now for example, here this is nothing but our suffix array. If we take B equal to 3, then we are storing that 1 2 3 under this, then 19 under 19 we are storing 11 40 and 30. If we take B equal to 2, we are making 60 50 28 19 11 40 and 30 location entry. So in this way, by selecting the particular choice, we select the supra index. So here in this example, B is equal to 3 is given, that's why later they are, for representation they are showing only 4 characters. So for example letter, and under letter mid and many, that is 50 and 20 is get stored. For text dot and words, and for text is next 33. So in this way we are creating the supra index. Now see the next example. Text is there, the sky is blue, the ocean is vast, the blue ocean meets the blue sky. So here if we want to make the supra index and the suffix array suffix tree, then we require to find out the particular keyword. So key terms are sky, blue dot, ocean, vast dot, meets blue and sky. So here stemming is not used, but if we want we can use the stemming also here. But when we use the stemming, at that time there is no use, as such no use of suffix array, because we want to find out the pattern of original text, that is original text should not be changed, that's why stemming is avoided here. Now here blue dot is different from blue, and sky dot is different from sky. Now this sky comes at 5th location, blue dot comes at 12th location, 22 comes at ocean comes at 22, vast dot comes at 31 location, then again blue comes at 41. So this blue and this blue is different. Then ocean again comes at 46 location, so ocean is present at 22 as well as 46. Mids come at 52 location, blue comes at 62, and sky dot comes at 11 location. So in this way we require to find out that particular location. This is very easy, only we require to make this count. For example, this 1 2 3 4, and again the sky will start at 5, so 5 6 7 8 is again space. So in this way we require to maintain that counter, and it is very easy to create the suffix arrays and suffix tree for a given text. Now once we found out all, we are making the suffix array. So here we are storing in a ascending order, so blue, blue dot, mids, ocean, sky, sky dot, vast dot, and they come at the location, at this particular location they are coming the words. So this is nothing but suffix tree and suffix array. So we can search by the blue also and by the blue dot also. Now here the 3 blue words are there, mids, ocean 2 times, sky 2 times, and vast 2 times. Now if we check that key, for example, if we make the supra indexing based on the word change, so we can make that the words which starts with the blue comes under one section, the words which starts with the M comes under one section, the words which start with O, S, and vast. So in this way also we can create the supra index, and if we want at a particular value of B, we can create also. So if we create at B equal to 3, then 1 2 3, so blue, this next 2 location comes under this, then 52 mids and next 2 location, then 5 sky and next 2 locations comes under this. So searching becomes very easy when we make the supra indexing. Otherwise with the suffix array, for retrieving the data or for searching the data we require more time, but with supra index the searching becomes very faster, or we require less number of disk access when we go for the supra index. Now here we can make like this. If we want to make in a detail, so this is blue, one without dot, with dot location, then this is trie structure, but here we are compressing this trie structure, so this BLU, they are same on the same path, so we just write down the blue, and the bifurcation is without dot, with dot. This mids we can write down up to M and last word. Then in this way we can create the compact version of the suffix tree. The crucial distinction between the inverted file and suffix arrays: inverted file sorts them by text position, whereas in suffix array they are sorted lexicographically by the text following the word. So if we create the suffix inverted file for this, then we are getting the table with 2 columns, that is first is vocabulary and second is the location where it comes, and the words are arranged in sorted order, and there is no distinction between letters and there is no distinction between text and text dot, words and words. So inverted sorts them by text position, whereas in suffix array they are sorted lexicographically by the text following the word. So here this is nothing but the text and text dot. So here this, even the words are same, but the 19 location comes first and then text dot, that is it is taking the text first and then text dot, words first and then words dot. Suffix trees enable efficient searches for patterns like word prefixes and phrases in O of 1 time through a trie search. Unfortunately, they become impractical for large text due to their complexity. On the other hand, suffix array provide a more feasible alternative, performing the same search operation in O log of n time using a binary search instead of the trie search. In suffix array, the search pattern is divided into 2 limiting patterns. A binary search is then performed on both limiting patterns in the suffix array, and to make this more efficient we can go for the supra index also. So here what is the difference between the inverted file and suffix arrays are suffix trees or suffix arrays are there. For example, if this is the text, the sky is blue, the ocean is vast, the blue ocean meets the blue sky. So if we want to find out the particular pattern in which, if we given in the search that the blue ocean meets, that is a double quote, blue ocean meets. So when we go for inverted file, it becomes very difficult because we require to find out that the blue ocean meets 3 words are there in that particular vocabulary. After that we require to check their order. So extra processing is required once that words retrieved from the vocabulary. Here it is not required because it is stored in the, if we see the array, so it is stored like this. So it is very easy to make the traces that blue ocean meets comes in a straight, or there is no difference, or they, if we keep in a double quote, it is very easy with the suffix array to match the pattern blue ocean meets. So this is the difference between in terms of normal query or the query with a particular pattern. And the suffix array and suffix tree are very efficient for such type of queries, and for simple single word queries or without no pattern, the inverted file indexing is better. So that's all about the suffix arrays and suffix trees. So these are the exercises for practice. The mountain is tall, the tall mountain has snow, the snow reflects sunlight. So for example, if we want to find out the particular pattern, that is mountains has snow or mountain slope, because we are not taking has for the indexing, so we can easily find out with the suffix trees and suffix arrays. So these 3 exercises are for practice. So these are the references. Thank you.